All right, so this is the warm-up to cover 1.3. A reminder that, let's say you get something similar to this on the test. It could be asking you to graph it, so you need your graphing calculator to graph it, and then answer the questions based on it. Okay, so make sure that you know how to do that. Obviously, I didn't give you an equation this time. It's just a picture. So it says to find f of 1. So I want to go to where the x is 1, which is here. Find the corresponding y, which would be good. And then find f of 2. So now I'm going to where x is 2. Find the corresponding y, which would be 4. Next question is domain and range. So domain is my left to right. The fact that these lines get cut off by the outside of the graph implies what? Good. These would keep going. My domain is going to be negative infinity to positive infinity. And the same for the range, bottom to top, negative infinity to positive infinity. If one of those stopped somewhere, obviously it would alter it. Number 4 says find the values of x for which f of x equals 0. 0, 0 is 1. So 0 and 3. Good. So because it just says find the values of x, you just have to give the x. If it asks for where the intercepts were, you'd give it in point form.
Oh, so it's just asking where, like, what the values are when it touches 0.
Right. Remember that, like, it could ask for zeros, roots, x-intercepts, where f of x is 0. All of those mean exactly the same thing.
Because f of x is kind of saying y.
Exactly.
Would it be wrong if we put it in coordinate?
I don't know if I'd actually cost you the points. Just make sure that you'd have both 0, 0 and 3, 0. Yeah, that's okay. The other way around, I would probably take out points. So if it said, what are the x-intercepts, I want it in point format, and if you just gave me a list of, then I would probably take off points. But this, if you give too much information, I'm less inclined to take points off than if you don't get enough. All right, 5 says state which interval the graph is increasing or decreasing. And so remember that it says increasing, decreasing. Sometimes it'll say describe the increasing, decreasing behavior, but it means include constants too. So this graph doesn't have a constant part, but if it did, you would make sure that you would include that as part of the behavior. Okay, so it sometimes, most of the time actually, won't say increasing, decreasing, and constant, but it's implied. So I'm going from left to right on my increasing and decreasing behavior. This first path would be what? Decreasing. So I could say it's decreasing from, and I'm doing the x values, right? So
Negative infinity to 0.
good. Negative infinity to 0. 0 gets a bracket or a parentheses. Parentheses. But you're doing the x values. So the only time you're going to do the y's are when it asks for the range, really. Everything else is going to be in terms of x values. All right, then the next shift goes from here to here, which is what? Increasing.
From 0 to 2.
Good. 0 to 2, parentheses on both, and then it goes back to decreasing.
Wait, why does the 0 get a parentheses?
Because that point cannot be increasing or decreasing. So a point itself will never get a bracket if I'm describing it as increasing and decreasing. A point's a dot, right? It's not moving up, it's not moving down. The only time you're going to see a bracket on a point is if it's starting or stopping constant. So if my graph on all the way on the left starts constant, or my graph all the way on the right stops constant. Those are the only times you're ever going to see a bracket on increasing, decreasing behavior. Okay, so we decrease back here from 2 to positive infinity.
Wait, I'm sorry. You said it's going to be a bracket only if it's constant?
Only if it starts and stops constant. So even if it's a constant point that's shared by a decreasing curve, I can't use a parentheses there. I can't use a bracket there.
But only when it's there.
Right, so it would look like this. Say it's that, right?
Mm-hmm.
This section here, from here to here, would be constant. It starts constant, so that would get the bracket, whatever the number is here. And then this one would get a parentheses because it stops being constant and starts being decreasing. And you can't have a point that's both constant and decreasing. So the only time you're going to get a bracket is if it starts or it stops. So reverse this. Let's say it looks something like this. I don't know. Down and then stops here. So it's actually decreasing, 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 and then constant and ends constant with a bracket.
And that's for all the other ones too.
Yep. Does that make sense? Yeah? Okay. All right, so then 5 says state all relative max or min values. So I've got a minimum here, right, a relative min, which is at 0, 0. And then a relative max here, good.
For decreasing, wouldn't you have to put like the other part after the 0, 2?
I have 2 to positive infinity. Yeah, oh, I just wrote them both under the decreasing. Yeah, so you don't have to separate them out. You can if you want to, but you don't have to. Any other questions in the warm-up? Yep.
So like for example, it's on the y, it's like infinity.
Yep.
For the range. Why is it positive infinity?
For the range?
Yeah, for the range.
Because you're going from bottom all the way up to top, right?
Okay.
So you always go in order of the value of the number, which means you start at the negative infinity and you always go up to positive infinity. Anytime you give it in interval notation, your order should be the same as the value of the number. So the smaller number comes first, biggest number comes second. And because the arrows are pointing down and up, you've got both negative infinity to positive infinity. Any questions on the homework that you're like maybe confused on in the homework?
Does the domain and range always have parentheses?
No. Domain could have a bracket and a parentheses, or it could even have 2 brackets, right? If I just went from dot to dot. So say that's your graph, right? That's a bracket to a bracket, domain and range. So it just depends where there's an arrow is a parentheses with an infinity or negative infinity, but if it's a solid dot, then it would be a bracket. If it was like an open dot, now my domain goes parentheses to bracket.
I've had it's only bracket if it's a straight line.
That's increasing, decreasing behavior, not domain and range. Oh boy. Okay, so this said find the open intervals, which the function is increasing, decreasing, constant. If the answer doesn't, oh, that's the none. Okay, so increasing on this graph, right, is going to be from here to here, which is going to be from 2, and that's cut off, which means from positive to positive infinity, because it's going, right, as you move to the right, it's increasing. This would be decreasing, so it'd go from negative infinity to negative 2. Both of those are going to get a parentheses because increasing and decreasing can't have a bracket, right? Point can't be increasing or decreasing. If it was solid across here, like let's say this went like this, that would be constant. And it would be from negative 2 to positive 2, but because those points are shared by another interval in which is increasing or decreasing, those also get parentheses.
There's always going to be an infinity when it goes off the graph.
Correct.
And that's only when it's going to be infinity.
Or if there's an arrow. Yeah, like if it stops ahead beforehand, but it has an arrow. All right, so you're good on the not function, right? The fails a vertical line test. So if I wanted to enter this equation into a graphing calculator, I've got to solve it for y. Otherwise, most of your graphing calculators anyways won't change to an x equals. So I just take that equation, x minus y squared equals 2. I'm going to subtract the x and then square root it. Actually, I have to multiply by negative 1 first, so that it goes positive y. And then square root it, but when you square root, you got to make sure you do the plus and minus. So it should have been plus and minus the square root of x minus 2, or negative 2 plus x if you wrote it the other way.
I feel like I tried to enter that.
I mean, it depends on how. Did you have the square root? Because the one you've got there doesn't have the square root.
No, like I tried to enter it with square root.
Okay.
I think.
All right, so 1.4 is all about transforming graphs. So if you remember shifting graphs up, down, right, left, making them stretch vertically or shrunk vertically, okay, or horizontally, all that stuff is 1.4. So I would say 1.4 is an estimation of what graphs look like, okay? A lot of these points are not going to be exact, but hopefully we can at least approximate what they look like. And this is really good for like standardized tests if you've got multiple choice on graphing. This saves you a lot of time. So common graphs to start with. A constant function would be an f of x equals a number. This is going to be a horizontal line. Think about your domain there would be negative infinity to positive infinity. The range is going to be a single number because the y never changes. And it is constant for the entire graph. So it would be constant from negative infinity to positive infinity. The f of x equals x is called an identity function. This is just like y equals x. So it's going to be a line that passes through 0, 0, and the slope's 1. So you're going to go up 1 and over 1, up 1 over 1. Okay? Domain, negative infinity to positive infinity. Range, negative infinity to positive infinity. And this time it's increasing the entire time. So we start basic and then we'll start to get a little bit more complicated. Absolute value, square root, quadratics, and cubic functions. So all of these are going to be part of what you'll be expected to transform. The absolute value is the v. The square root is obviously the square root. The quadratic would be an x squared. And the cubic function would be the x to the third. So you've got to know the basic shapes of these. These are called your parent functions. Okay, it's going to say what's the graph of the parent function, and then what's the transformation. So am I shifting it to the right, to the left, up, down, narrow, wide, all that sort of stuff. So notice that this section is called the transforming functions, right? So what should be true about all these graphs? They're all going to pass the vertical line test, okay? Otherwise, it's not a function. So you won't get a sideways v, okay? Because, God bless you, because that would fail the vertical line test, and that would be the y is an absolute value, and you can't put f of x in absolute value, okay? So you're going to see f of x equals something, and all of these graphs should pass your vertical line test. The cube root function almost looks like the square root pointing onto the right, and then if you were to flip it over the origin pointing to the left. And then the last one is the reciprocal function. The parent function starts in the top right corner and the bottom left corner, or the first quadrant and the third quadrant. And this would be a 1 over x. So if you remember asymptotes, there's technically two asymptotes going on here, one here and one here where it wouldn't cross over those, okay? Ian?
Why does it say odd function?
It's just that it is an odd function, right? Because it would be symmetric to the origin. So would the cube root function, right? Those would both be odd. To remind me to go over it, and I forgot, so good job. Questions on either of those? So again, you want to memorize what the parent function looks like, and then we're going to figure out what happens when we start shifting these around. So a vertical shift, no matter what's going on with the x, okay, that's going to be determined by your parent function. So the fact that it's absolute value means it's a v. The fact that it's a square root means it's the single arc going to the right. The squared is a parabola. The cubic function is the one that goes up on the right and down on the left, right? So that's telling you what does the actual parent function look like. If I add something after the function, so after the absolute value, outside of the square root, outside of the squared, or outside of the cubed, if I add, it's going to shift it up. And if I subtract, it's going to shift it down. I'll add in there f of x. So the cube root function could also be part of this. And the reciprocal function, it would be after the fraction. So if I'm adding or subtracting, I'm shifting up or down. Adding is up, subtracting is down. So the directions will say, graph the function. Here I just gave you some square root ones, some squared ones, okay? But you should get the general concept. If the first thing you should be saying is, what does my initial graph look like? What's the parent function of f of x equal x squared? Parabola. It's a parabola. So if it asks you to describe it, you could either write a parabola or you could write a quadratic function, okay? If it asks you to draw it, you're going to draw your typical, just your u with your vertex being at 0, 0, okay? So if that's I'm saying that's the parent function, right? And then if it said, now shift it, right? What's going to happen is my graph is going to get shifted up one place. It's still a parabola, okay? So that's your end result, would be shifted up one place. No, it'll just say graph. So I said if it said graph the parent function and the shifted graph, then you'd have both of those. If it didn't say it, then I would just do the purple, the ending graph.
So that
Is that purple graph that's right there. Just graph it, okay?
Does it matter how wide it is or how?
So what's going to happen, you're eventually going to see that the horizontal stretch, and so I'm going to compare it to your regular. Like, you're going to label it for me if it's supposed to be stretched. So if it doesn't, like 10 seconds, you'll see it, not 10 seconds, but about a couple minutes. When it is stretched, you'll identify it as being stretched by literally writing like narrow or wide or stretched vertically or horizontally. And then that's, I know the difference between your normal and someone else's stretched. You'll tell me when you intend for it to be different, okay? So your typical parent function, you don't need to write it. Or just shift it up or down, not until we start stretching it vertically. Does it matter?
you had to put it on one because it's buffering.
Correct. So that's the only exact point on my graph. Everything else would be an approximation. If I asked you to plot additional points, then I would plot to the right of the vertex, to the left of the vertex, and at least get a little bit of a curve. But for right now, we're just approximating. So what happens with B? Shift it down 2 places. So again, vertex would now be at 0, -2. And it would be pointing up. Good so far? Yes? Okay. Horizontal shift happens inside the function. So if it's inside the absolute value, underneath the square root, inside the parentheses, or in the fraction for the reciprocal function, so it would look like this if it was cubic. And it would look like that if it's a reciprocal function. And for this one, it's the opposite. So if you're adding, you're actually moving to the left, and if you're subtracting, you're moving to the right. So inside the function is a horizontal shift in the opposite direction. All right, so again, we've got the same parent function. I just kind of kept the parabola, keep it simple, but inside those parentheses is a -2, which means what?
2 to the right.
I'm going 2 to the right. So I'm going over to 2, 0, and I'm making my parabola that points up. Obviously, they're going to start to do more than one thing at a time, right? So B has a +2 on the inside, which means what? Left 2. And then -3, which means down 3. So I don't care if you move left or down first, as long as you do both at some point. So I'm going to go left 2, down 3, I'm going to plot a point. And then my parabola is going to point up. All right, then there's a reflection. So if the negative is on the front of the function, then it flips it across the x-axis. It flips it upside down. So my u would flip upside down, okay? My v would flip upside down. My cubic function, instead of going up to the right, down to the left, would be up to the left, down to the right. And the square root would flip upside down. So instead of it pointing up and to the right, it would point down and to the right. If the negative is inside the function, then it flips it across the y-axis. So for a square root, instead of pointing to the right, it's going to be pointing to the left.
And that's the case for all of them?
Well, but most of them don't matter, right? Most of them, you flip a v, it looks the same, left to right. You flip a u, it looks the same, left to right. The ones it's going to impact are the cubic functions, the reciprocal functions, and the square root functions. So the same is going to be true for, although a negative,
So it'll be cubic, square.
although they're the same, whether you're flipping it upside down or not. These are the ones that are going to flip across the y-axis. But again, whether it's a cubic with a negative on the front or on the inside, the cubic one looks the same, or the cubed one looks the same, because I can point it.
Points left, 'cause usually those
So
are
if
from the
my
right.
parent function is square root, right, typically my square root function looks like this,
Oh, yeah.
right? The square root with a negative on the front flips it so that it's upside down. Now I'm pointing down but to the right. And then a negative on the inside points it left. So up but left. And then if it was both places, it'd be down and left.
You can do that?
Yep.
Cool. You can look both places or
It goes down and left here. Here's the best part. If you're unsure, what could you do? Graph it, plot a point, right? If I don't know if it's going up and to the right or if it's going down and to the left, plot a point. Okay? The idea is that transformations help you do it quicker. Okay? But it is less precise. So if you are unsure, then just plot a point. All right. So looking at A, I've got a negative on the front. Well, first of all, the parent function is what? Square root. So it's going to look like this. That's what my parent function would look like. The negative on the front does what?
flip it across the X.
Good. I say upside down because people start to mess up across the X, but it's definitely the more technical term. Upside down. The plus 1 on the inside does what?
Right.
Left 1. So I'm moving left 1. I'm plotting a point. Typically my graph would look like this, but it's flipped upside down, so it looks like that. For B, the negative is now on the inside, right? So it's going to point left. And the plus 3 after the square root means up 3. So I'm going to go up 3, plot a point, and point it left. All right, non-grid transformations. This is your stretching and your shrinking, okay? So if the number is on the front of the function, okay, and the number is bigger than 1, we're not talking about positive and negative, right? Because positive and negative is a reflection. So the absolute value of whatever's there. If it's bigger than 1, then there's a vertical stretch, okay? As though you tied a string to the top of the graph and you're pulling it vertically. So if it's an absolute value, it gets more narrow. If it's a square root, if it's a parabola, it gets more narrow. If it's a square root function, it would get taller. So kind of picture what a vertical stretch would do. If it's in between 0 and 1, so now it's a fraction, that's less than 1, there's a vertical shrink, okay? As though the ceiling was collapsing in on your graph, which will make it wide, okay? You can say vertical shrink, okay? Or if it's a if it's a square root function, it's going to make it flat. So when you go to graph these shifts, you need to let me know what your intention is on them, okay? Because your standard graph might look different from someone else's standard graph. So if I'm going to graph something that's supposed to be more narrow than normal, then when I graph it, I'm going to not only draw it, but I'm also going to add here narrow or vertical stretch. And that way I know what your intention was, okay? Because these are approximations, you're going to be a little bit different. All right, so the parent function on these are what? The V, good, absolute value. The 3 on front makes it what? Narrow or stretch vertically, right? So my 0 is still here. But basically, if I was going up and over 1 before to get my standard, I'd be going up 3 and out 1. That's the idea behind it. So it's almost got like a slope on it. But you want to just make sure that you add on there narrow or stretched. How about 1/2? 1/2 is doing what? A shrink. So this is a vertical shrink, or it's making it wider or flatter, anything like that, okay? So basically, again, same point as that 0, 0, but instead of going up 3 and out 1, I'm going up 1 and out 2. So that's kind of how this works. It's almost like a slope on here. You're just going to make it more wide or vertical shrink.
It doesn't matter what we
Nope, as long as you identify to me one or the other. So shrink or wide or flat are fine. Narrow, tall, or stretch are fine. Yeah. Whatever makes the most sense to you. Questions so far? All right, so then something like this kind of puts it all together. So it's asking you to identify the parent function, describe the sequence of transformations from the parent function to what we've got, sketch the graph of it by hand, and then use function notation to write g in terms of the parent function f. And I'll show you what that means when we get to it, okay? So what's the parent function? Parabola, okay? But what is it in f of x form? X squared. B says describe the sequence of transformations from f to g. So let's break this apart. What is the 3 on the front doing? It's shifting it up 3. So this is an up 3. It's separated by a plus or minus sign. That's your vertical shift. It's a positive 3, so it's vertical up. What's the 2 on front do? Narrow. Good. Narrow or stretched vertically. What's the minus 4 inside the parentheses do? To the right 4. And then obviously my parent function is the quadratic. So you can write that out in words, or you could do it just like I just did. Okay? For me, that's enough, as long as I can see the break apart. So now I'm going to go to my graph. I'm going to go to the right 4. I'm going to go up 3. There's my vertex. I know it's narrow, and I know it's positive, so it's pointing up. And there's your graph. Now, when it says sketch by hand, I want to be really clear on homework that does not mean use your graphing calculator in your hand. It means use your graph, okay? You should be able to do that on your own. All right, D says use function notation to write g in terms of parent function f. So basically what I have to do is use that f of x to replace the x squared. And I'm writing 1 in terms of the other. So instead of the x squared, I'm actually going to write f of x. Now what am I doing to that x in my shifted function? What's after x in the shifted function? Minus 4. It's the same exact thing as going to carry over. The only difference is I'm already saying that this is squared. So all I have to do to this is now multiply it times 2 and add the 3. And I've taken my g and wrote it in terms of the f of x. So there is more than one way to do this, okay? So don't freak out if it's not exactly the same. But that's your idea. If we're saying f of x is x squared, and I want to shift it 4 places to the right, and I want to make it narrow, and I want to shift it up 3 places, okay? I'm just basically eliminating the x squared part and replacing it with f of x. And again, you could do this in a couple of different ways. So don't freak out if it's completely different, as long as your shifts are the same. All right, a couple of questions came up in the last add-on here. Try to think of what we did. All right, so let's think about what's happening here. See if you can do it. See if you can graph it, and actually this would be a g of x because it's not. Typically the f of x is the parent function and the g of x, not that it's a huge deal, it doesn't really change much, but the g of x would be the shifted one. So see if you can graph it, and then see if you can give me your domain and range. All right, what's your parent function? The hard part. Square root function, right? What's the negative 2 at the front do? Down 2. What's this do? What's the negative in front of the, because those are 2 separate things, right? Let me actually move that arrow over. This negative is not part of that 1/2. What does that negative do? Upside down. What's the 1/2 do? Wide or flat, right? What's the negative under here do? Good. Over the y. Oh, I should have grouped it. And I need another color. And the plus 3. It should move it to the left 3. Okay, so now pay attention to how you do this because you can do this two different ways, okay? So the shifts and the like your typical shifts are the same. I'm going to go down 2, so I scoot down 2. Normally, I would go left 3, so I go 1, 2, 3. I'd plot a point, okay? And then the upside down would mean it would be pointing down and be flat. So it would be pointing down, it'd be flat. So I've done everything except for the shift over the y. Everybody with me so far? Now if I shift that over the y, I'm now going 1, 2, 3. My point is here, and it's pointing this way. So you basically approach this 2 different ways. One, the way we just did, do everything except for the over the y, and then flip it over the y. The other way, and some people think this is easier, so whatever works for you, you do. When you have a negative underneath the square root and there's also a horizontal shift, then allow this minus to change this sign, which would make that a negative 3, which would really mean I'd be moving to the right 3. I just remember to point it left. So if you're going to do that, that's fine. You don't have to do the original and then flip it over the y, but you want to make sure one of those makes sense to you. So you're either graphing it without the over the y first and then flipping it over the y, or if there's a negative here, you let that negative change the direction of that positive 3. So normally it would go left 3. Instead, I go right 3. And then I make sure I point it left instead of flipping it over the y. Okay?